Good day, everyone. So today we shall be diving into gears, and we'll be looking at the gear ratio and gear speed. We'll look at the definition of gear ratio and the speed, and as well as the step-by-step reasoning for gear ratio and gear speed. So come with me, let's dive into this topic. So first of all, what is gear ratio? Gear ratio compares the driven gear to the driver gear. That is, it relates the teeth counts or the input and output speed. Okay, when we are comparing the number of teeth of the driven gear to that of the driver gear, then you're talking about the gear ratio. Okay, so you can see here now in this diagram on our left hand side, you see that the number of teeth of the driver gear is most likely more than that of the driven gear. Then when we compare the two of them, then we are talking about their gear ratio. So what's the formula for gear ratio? Gear ratio is simply calculated by dividing the number of teeth on the driven gear by the number of teeth on the driver gear. So by formula we say that gear ratio equals number of teeth on driven gear all over number of teeth on driver gear. As simple as that. So that's what we use in determining gear ratio. Once you know the number of teeth on the driven gear and you know the number of teeth on the driver gear, you just divide them, and that will give you the result. Okay, so that's the formula for gear ratio. Let's see an example on that. Question here says, calculate the gear ratio if a gear with 15 teeth is used to drive a gear with 30 teeth. So definitely the gear with 15 teeth that is driving the gear of 30 teeth is definitely the driver gear. So the driver gear has the number of the other 15 number of teeth, while the driven gear has 30 number of teeth. So making our formula, gear ratio simply is number of teeth on driven gear all over number of teeth on driver gear. So we'll bring that in. Number of teeth on driven gear is 30 and that of driver gear is 15. So that will give us 15 in 30 is 2 and 15 in 15 is 1. So that is 2:1. So instead of putting the division sign, we use the ratio sign. So the gear ratio of these two gears is 2:1. Right? So let's talk about what we call the series of gears. So sometimes you might have more than two gears, okay? You might have more than two gears driving one another. So in that case, how do you calculate the gear ratio of more than two gears? Because in our previous example, like I just shown here, we only have two gears here, the driven gear and the driver gear. But there's a situation where the driver gear here drive this one, which becomes the driven gear by this. Now this becomes the driver gear for this. How do you now calculate the gear ratio of the three gears? It's very simple. It's simply by multiplying the gear ratio of each of them. Okay, simply by multiplying the gear ratio. Let's see an example on this scenario. Okay, look at this question. It says, if a 20-tooth driver gear drives a 24-tooth cluster gear, and the second speed cluster gear has 16 teeth, driving a 20-tooth second speed driven gear. Calculate the gear ratio. Okay, now gear ratio generally is the formula is number of teeth on driven gear over number of teeth on driver gear. So we are going to take the gear ratio one at a time. Now the first sentence said a 20-tooth driver gear. Okay, so we have driver gear here, the fourth driver gear, that is 20. drives a 24-tooth cluster gear. So this is the driven gear. So when you calculate the gear ratio 1 will be 24/20. That's it. Now we move on to the second sentence. It said, and the second speed cluster gear has 16 teeth, driving a 20-tooth second speed driven gear. Okay, so this 16 teeth of gear is the driver gear of this 20 tooth. And then for us to get gear ratio 2, you're going to be number of teeth on driven gear, that gear ratio 2 now, over number of teeth on driver gear, that was 20/16. So what now the overall gear ratio will be? Gear ratio 1 multiplied by gear ratio 2. So gear ratio 1 value, we have it as 24/20, is it here? Multiplied by gear ratio 2, which is 20/16, which is this. When you multiply this, you will get 1.5. That is 20 cancel 20, so we have 24/16. And 24/16 will be giving us 1.5. Now this can be expressed as 1.5 ratio 1, because 1.5 is not a ratio, but you say 1.5/1 is the same thing as saying 1.5 ratio 1. So the overall gear ratio of all the gears in this question is 1.5 ratio 1. So that is how you work with series of gear. If you want to determine the gear ratio, the overall gear ratio, you determine individually the gear ratio of one pair, and so on and so forth, and then you multiply them together. That will give you the overall, as we have just done in this example. Okay, so we cannot go to the gear speed. I don't know what gear ratio is. What is now gear speed? Gear speed measures how fast a gear rotates. Okay, that is revolution per minute. The RPM there represents revolution per minute. So how fast a gear rotates in a revolution per minute, that's the unit of the speed now. Now, speed is inversely proportional to gear teeth when measured. What that means is that the fewer the teeth of the gear, the higher the speed of the gear. So a gear with higher speed will higher teeth will reduce the speed, or we have a reduced speed. So fewer teeth, higher speed. Higher teeth, fewer lower speed. So that is why we say speed is inversely proportional. That is, as one is increasing, the other is decreasing. So as the teeth increases, then the speed of the gear will decrease, and vice versa. So what is now the relationship between two gears that have speed? Imagine you have gear B that has teeth T, gear B that has T2 and speed N2, and you have gear A that has teeth T1 and speed N1. How do you compare this? So by proportional law, the formula to compare the gear speed is this: T1 times N1 equals T2 times N2. That is, the number of teeth of gear A times the speed of gear A equals the number of teeth of gear B times the teeth of gear B. Okay, that's it. So this is what we use. This relationship lets you solve for an unknown speed. So it is either you are looking for the speed of one and the other one is given. One of them will be missing in any problem we solve. Okay, so let's see a work example here. Here is a gear has 20 teeth. A gear has 20 teeth. Its speed of rotation is 10 RPM. The gear drives another gear with 10 teeth. Determine the speed of the 10th tooth gear. So we are given the first gear with its number of teeth to be 20. That is T1 is 20. And that is speed of 10 RPM. So N1 is 10 RPM. That's a revolution per minute. And then the second gear has a teeth of 10 teeth as well. So we have T2 to be 10 teeth, but we have determined the speed of the second gear, which is our N2. So make use of this formula and substitute it correctly, where our T1 is 20, our N1 is 10, that will be 20 times 10. This dot between them is times. So 20 times 10 equals, our T2 is 10, then our N2 is the unknown. So from there, our N2 will be 20 times 10 all over 10. So the speed of the second gear will be 20 RPM. It's as straightforward as that. It's very simple. There are other cases where the speed of the second gear will be given, and then you'll be asked to find the speed of the first fourth gear. So the speed of the second gear will be given rather, and then you have to find the speed of the third gear. So any of them can be unknown, but only one of the variable will be unknown, while the rest will be given in the question. So to take note of that. So I want to say that what is our key takeaway in this topic when we have talked about gear ratio and gear speed? So in summary, we say that gear ratio is equals to driven gear number of teeth divided by driver gear number of teeth. Okay, and we say that when we have more than 2 gears in series, all we need to do is to multiply the individual pair ratio to get the overall ratio. And lastly, we talk about the speed of gear, the gear speed. And the gear speed, we say that the gear speed is inversely proportional to the number of teeth. Okay, and the formula here is that T1 multiplied by N1 equals to T2 multiplied by N2, as we have solved in our previous slide. So I'm going to be drawing the curtain here. I hope you have learned something today from gear ratio and gear speed. Thank you for watching and have a wonderful day. Bye.